Okay, should we get started? If we can catch up on time with that. So, for some reason I missed this slide last week, I'm not quite sure why. So on second degree price discrimination, remember we were looking at this two-part tariff, which we said was a form of second degree price discrimination. You can use the two-part tariff to extract different degrees of surplus from high and low types. And then in the class, we went through this exercise and we showed that with a two-part tariff, the high types strictly prefer the quantity and price they're getting to what the low types are getting. Okay, so the high types are getting surplus from consuming their bundle. So a clever firm could charge, slightly change these bundles in order to extract some extra surplus out of the high types. Okay, so this is a graphical argument that's going to show how they might go about constructing optimal bundles. Okay, so the firm is going to offer consumers a choice between some quantity and some total cost, and some other quantity and some other total cost. Okay, and these total costs, I'm expressing it in terms of these areas on the demand curve. So this might seem a bit magical, where this B plus CQL and where all this is coming from. It will all make sense once we get to the end. Okay, so it's like we're I'm telling you what the answer is, and I'm going to show you how we get there. So we're going a bit backwards. So the firm is going to offer a choice between these two bundles. So this means get this quantity, pay this total cost. You get this quantity, pay this total cost. The firm wants to design these bundles such that the high type consumer wants to consume this bundle that's designed for them, and such that the low type consumer wants to consume this bundle that's designed for them. Okay? And what the firm's going to do is going to choose the total cost of these bundles so that the low type consumer is just indifferent between consuming the bundle and not getting anything at all. And the high type consumer is just indifferent between consuming their bundle and consuming the low type's bundle. So let's see if these values actually manage to do that. Let's look at the low types first. Okay, so if the low types take the first bundle, this one that was designed for them, well, they get to consume a quantity QL, which is here, okay, and they're paying a total of B plus CQL. So CQL is this area here, B is this area here, so they're paying all of this. This is their demand curve, PLQ. So they get this in surplus, they pay all of this. Okay, so low type consumers getting zero value gain overall. Okay, they're just indifferent if they take the first bundle. Okay, they pay this area, they get this area back in surplus. If they take the second bundle, okay, then they get a quantity QH. So now, if you like, their surplus is all of the area under the curve from here up to here. Okay? So what we're going to do is we're going to split that. First, let's take this area of this big box. What's this area of this big box? Well, this is C times QH. Okay, but F here isn't included. So F is included in the big box, but it's not included in their consumer surplus. Okay, so we have to subtract F away. So if you like this area, okay, so this box but without F, that's C times QH minus F. And then they also get B plus D. Okay, so that's what they gain from consuming. Which I should have written down here somewhere. So they get B plus D minus F plus CQH. Okay, this is what they gain from consuming, but they pay this quantity here, B plus C plus D plus E plus CQH, if they take the big bundle. Well, most of these terms cancel out. The B's cancel, the D's cancel, The CQHs cancel. Okay, so what you're left with is the remaining terms. So you have the C left, an E left, and an F left. Okay, so you have minus C, minus C, minus F. These things are all positive, so this thing is negative. So if low-type consumers take the first bundle, they get 0 surplus. If they take the second bundle, they get negative surplus. Therefore, low-type consumers are always going to take the first bundle. Okay, and if a firm just marginally lowers the cost 1 penny, they're going to strictly prefer taking the first bundle to not taking anything at all. So the low-type consumers are acting as the firm would like them to act with these bundles. Okay. What about the high-type consumers? Well, the high-type consumer has this higher demand curve. Okay. If they take the first bundle, then they get to consumer quantity QL. So their surplus is all of the area under the curve. Let me see. Either way. So they get CQL plus B plus A. Yeah, so A plus B plus CQL, but then they pay this cost that was specified at there, B plus CQL. Okay, so they're left with a surplus of A. So if a high-type consumer takes this bundle that was designed for the low-type, they get a surplus of A. What about if they take the second bundle? Well, if the second bundle says they get to consumer quantity QH, so their consumer surplus is going to be C times QH, which is this big rectangle, plus E, plus D, plus C, plus B, plus A. Okay, so it's A plus B plus C plus D plus E plus CQH. But then we've specified that the cost of the second bundle is this thing up here. So again, most of these terms are going to cancel. So B, C, D, E, and CQH are all going to cancel out. And what they're left with is a surplus of A. Okay, so if the high-type consumers take the first bundle, they get a surplus of A. If they take the second bundle, they get a surplus of A. Okay, so if the firm just gives them 1p of extra surplus, so reduces this by 1 penny, then they're going to strictly prefer to take the high-type bundle. Can the firm do any better than this? Well, the low types are just indifferent between consuming this bundle, paying something to the firm, and not consuming anything at all. So if the firm tried to extract anything else from the low type consumers, the low type consumers would just stop buying altogether. Okay, so the firm can't extract any more from the low type consumers. A high type consumers, well, if a firm tried to increase the cost of buying the high bundle, then the high type consumers would just buy this bundle designed for the low type consumers. Okay, so the firm can't extract anything else out of these guys like that. So what's the firm's profit going to be? Well, if you like, it's selling 1 unit to a low type, 1 unit to a high type. So the CQL, obviously it has to pay this marginal cost of C. Okay, so from selling to the low type, it's going to make a profit of B. From selling to the high type, it's going to make a profit of B plus C plus D plus E. Okay, so in total its profits are 2B plus C plus D plus E. And you can think of that as the sum from A up to E plus B minus A. Why would you want to do that? Well, this thing, A plus B plus C plus D plus E, that's this area here. Okay, and that doesn't depend on the quantity that the firm is offering to the consumers. Okay, that area, sum from A up to E, is just determined by the high type demand curve and the marginal cost line. So there's nothing the firm can do to affect A plus B plus C plus D plus A. The other term, B minus A, so it's this area minus this area, that's something that the firm can do something to affect. Right? So what the firm would like to do is they'd like to change the quantity that they offer to the low type in order to maximize B minus A. So So, if you take the first order condition, what you're going to get is that the derivative of b with respect to a quantity offered to the low type should equal to the derivative of a with respect to quantity offered to the low type. But these things are areas. Okay. So, can you give me a geometric characterization of these derivatives? What is this derivative of b with respect to QL? Can you show me that quantity on the graph, maybe? So as I increase QL by a little bit, what's going to happen to B? What's going to happen to A? Go on.
It's where the line at QL is. So the derivative of B is from C up to the low type line.
Yeah, I think I know what you mean.
And A is the part above.
So the derivative of B is just the length of this line, from there to there. Likewise, the derivative of A is going to be the length of this line. Okay, and you can, I can draw something to show you that. So what have we got? We've got something like this. Okay, I'm drawing this right. Okay, so here's B, here's A. Okay, here's QL. Well, what happens if we increase from QL to QL plus delta? Okay, then B increases by this area, A increases by this area. Okay, what is the area of this? Well, this distance is delta. This distance is the height of the line. Okay, so when we divide by delta to get a derivative, we're just left with the height of the line. Okay, likewise for A. So this derivative condition just means that at the optimum choice of QL, the length of this line should be equal to the length of this line. Okay, so the firm should choose the quantity to offer to ensure that happens. So from looking at the graph, at the moment it looks like this line is a bit shorter than that line. So maybe they want to reduce quantity offered to the low types of that. Okay. So that's how the firm can make the optimum trade-off between selling to the low types and selling to the high types. Note that the high types are still getting a little bit of consumer surplus. Okay, so there's nothing the firm can do to completely take away all of the consumer surplus of the high types. And this is, if you like, the difference to first-degree price discrimination. With first-degree price discrimination, I said that it wasn't incentive compatible. People who really valued the good would like to pretend to be people who didn't value the good. Okay, because with second-degree price discrimination, you have to make it incentive compatible. You have to encourage the high types to act as you want them to act. You have to give them a little bit of surplus. Okay, so the firm can't quite get all of the surplus. So as a result, yeah, that's what I was. Okay, so that was everything I had to say on second-degree price discrimination. The one type of price discrimination we haven't talked about yet is third-degree price discrimination. Okay, so to remind you, first-degree price discrimination was making everyone a different take-it-or-leave-it offer, if you like, based on what you know their valuation of the good is. Second-degree price discrimination was getting firms to select into different groups. Third-degree price discrimination is making different offers, but based on some observable characteristics. Okay, so if you like, third-degree price discrimination is a more practical version of first-degree price discrimination. So we talked about student discounts last time. Student discounts are a classic example of third-degree price discrimination. Okay, the firm thinks because you're students, it knows something about what your demand curve might be. Okay, and it's going to offer you a slightly different price to people who are students. And there are lots of things. OAPs get discounts on things as well. If you go to a conference in economics, the rate for academics is always a lot lower than the rate for people from business. Magazine prices are different in different countries, even though it's the same content. Even if you buy online, even if it's just an online subscription, the price is still different, and the reason is that they think people in different countries can afford to pay different amounts. This is probably out of date. So So yeah, the rest of the EU is 580, but poor old Greece has 540. So maybe that's a bit insulting. Yeah, and membership of the American Economic Association, huge difference in prices across the country. Okay, so this is very common. You see this all over the place, and the more you look for it, the more you see it. Okay. So what the firm is going to do, because it can tell what type of market you're coming from, the firm is going to act like a monopolist in each of the markets. Okay, so the firm is going to be setting marginal revenue equal to marginal cost within each market. And we'll go through this quite quickly because it's fairly simple. So suppose you've got two types of consumers. So the type 1 consumers have some inverse demand curve P1 and Q1. Okay, so for price, type 1 consumers are prepared to pay as a function of the quantity that type 1 consumers consume. Likewise, type 2 consumers have demand P2 or Q2. The firm has some cost, total cost function, capital C of Q, okay, where Q here is Q1 plus Q2. So this isn't a Corno model, we don't have two different firms. This is the quantity sold to type 1 consumers and the quantity sold to type 2 consumers. Okay, so you're using the same production process to sell in two different markets. So what matters is the total quantity you produce. Okay, so what's the firm's profit going to be? Well, from selling to the type 1 consumers, it makes revenue of price 1 times quantity 1. From selling to type 2 consumers, it makes revenue of price 2 times quantity 2. And then it has this total cost, so the cost of producing Q1 plus Q2. So the firm is going to choose Q1 and Q2 in order to maximize their profits. So you're going to have two first order conditions, one for Q1, one for Q2. Let's just look at the one for Q1. Here we're going to use the product rule on this expression. So P1 dash is the derivative of P1. Okay, so this is P1 dash Q1 times Q1. P1 doesn't appear at all in this expression. Oh, sorry, and then we have the other term. So this term was the derivative of this times that. Now we have the derivative of this, which is just 1 times that. Okay, and that's that term. Q1 doesn't appear at all in this expression. So then we just have the derivative of this with respect to Q1. Okay, so by the chain rule, this is the derivative of the outside, so C dash Q1 plus Q2, times the derivative of the inside, but the derivative of Q1 plus Q2 with respect to Q1 is just 1. Okay, so it's just C dash. So it's not, this is almost exactly the same as what you've seen 1,000 times at this point. So what's this saying? Well, this is the usual marginal revenue expression, and this is marginal cost. Okay, so this is just saying marginal revenue from selling to firms of type 1 should be equal to marginal cost. And likewise, if you do the same thing for the quantity you sell in the second market, you get marginal revenue 2 equal to marginal cost. And there's a little exercise there. Do it in your own time. So let's see if we can say a little bit about what's going on with computers dying. Oh, Cowboy just crashed. Oh no. No, it's come back to life. Okay. So maybe we want to say something about which of these markets is going to have the higher price. So if you've read chapter 3 of Oz Shy, which you might have done in week 1, you might have seen something like this already, in fact. So here was our first order condition for third one. And what we're going to do is we're going to divide this equation by P1. Okay, so dividing this term by P1, you get this. Dividing P1 by P1, you just get 1. Dividing C dash by, you get that. Okay, so it's clear what we've done. So this thing here, this is the derivative of price times quantity over price. Okay, quantity over price times dp dq. So it's 1 divided by, so just flipping everything, 1 divided by price over quantity times dq dp. This you recognise as the elasticity of demand. So this is saying that this expression here is just 1 over the price elasticity of demand. So remember that the price elasticity of demand is normally negative. Okay. So once you know that this is 1 over epsilon, then this expression is that, what is it? 1 over epsilon plus 1 is equal to c dashed divided by p1. Okay, so let's invert both sides. So p1 is equal to c dashed times 1 over 1 plus 1 over epsilon. That's what I've got written. So the price is marginal cost divided by this thing, 1 over 1 plus 1 over epsilon. So when demand is elastic, epsilon is going to be big in magnitude. Okay, epsilon is going to be like minus 100 rather than minus 1. Okay, so elastic demand means epsilon is a very, very negative number. So 1 over epsilon is going to be close to 0. Okay, negative but close to 0. So this is going to be a number that's less than 1 but only just less than 1. Okay, so this is going to be close to dividing by 1, so price is going to be close to marginal cost. But if demand is inelastic, okay, then epsilon is a negative number but one quite close to 0, so it might be minus 1. Then 1 over epsilon is going to be a big negative, a larger magnitude negative number. So 1 minus 1 over epsilon is going to be quite close to 0. So this is going to be like dividing by something close to 0, so it's going to be very large. Okay, so with inelastic demand, the price is very high. With elastic demand, the price is low. Something we saw already in week 1. And because in both markets, you're getting the same expression on the top, marginal costs are the same for selling in both markets. So what's going to happen is that if one market has elastic demand and the other one has inelastic demand, in the one with inelastic demand, you're going to set a very high price. In the one with elastic demand, you're going to set a low price. Okay, so students, the thought is students have more elastic demand. I don't know, you have more free time so you can shop around more. Maybe that's another argument. Okay, so you want to set a lower price for students than you do for other people. And that's what motivates the student discount. What was I saying? Okay, so we looked at welfare with the other types of price discrimination. You might want to know if third degree price discrimination is going to be good or bad for welfare. And it turns out that it's ambiguous. Clearly the firm is gaining. Okay, the firm is able to, by a revealed preference argument. So if the firm can price discriminate, the firm always has the choice of setting the same price in both markets. Okay, so the firm could charge the same price to both students and everyone else. If the firm chooses not to charge the same price to the two markets, then that must be better for the firm. Okay, so if you like, price discrimination is increasing the possible choice set of the firm, so it can only possibly make the firm better off. Okay, the firm always has the option of setting the same price under price discrimination in both markets as it would under non-discrimination. So the firm is always going to gain, but consumers offered the high price are going to lose out. Okay, if the firm couldn't price discriminate and was selling the same price in both markets, if you like, it would be facing the average elasticity of the two markets. It's not quite true, but something like the average elasticity of the two markets. So it would be selling at a relatively lower price to the high-type consumers and a relatively higher price to the low-type consumers. So when the firm can price discriminate, consumers who get offered the high price, they're going to lose out. Whereas the students, people who are offered the low price, they're going to gain. Okay, and In some extreme cases, without third degree price discrimination, the low type consumers wouldn't have been buying the good at all. Some old papers of Varian, he showed that a necessary condition for a welfare improvement is that total output increases. Okay, so this is only necessary, it's not sufficient. That means that total output can increase and welfare might still go down. Okay, but any time welfare does increase, you know that total output must also increase. You don't need to understand the proof unless you're really interested. So it's intuitive. Okay, if output increases, people are getting more surplus, there's more total welfare being generated. So it's plausible that that's a reasonable condition. Okay, and the idea of why it might increase is that if you're selling a lower price to these to the low type consumers, then suddenly they're going to go out and buy a lot of the product. So let's just go through a simple example with linear demand. You all seem very quiet today. You've had a test today? It's that time of the month. You know what I mean? There's a kind of lull in the middle of the term. You can't quite see. I know what you thought then. You can't quite see Christmas approaching yet. But you've had all your midterm tests now, so at least you've got that. You've got more to go, yeah, I suppose so. You can't quite relax yet. Okay, so let's look at this linear demand example. It's going to be quite similar to the two-part tariff one we looked at. So we're going to have one type, the high type, they're going to demand 1 minus the price. The low type are going to demand A minus the price. A is going to be less than 1, so the low type demand less than the high type. And we're going to have 0 marginal cost for simplicity. The decisions... okay, so if you decide to price discriminate, if a firm is price discriminating, then from selling to the first market, they make 1 minus P times P. Okay, you've seen expressions like this a million times. So they're going to set the price in the first market to be equal to a half. Okay, so the quantity sold to the first market is going to be a half. Okay, this is just a quadratic. With the second market, the same thing again. So this expression here is 0 when P2 is equal to A. So you know that the maximum of quadratic is always halfway between the two zeros. Okay, so the optimum price must be A over 2. Okay, so again, the quantity is going to be A over 2. This is kind of first year economics again. So the total output is going to be quantity sold to the high types plus quantity sold to the low types. So 1 plus A divided by 2. Everyone happy? It's easy. If the firm decides not to discriminate, then the problem is a bit harder. Okay? If you're not discriminating, you have the choice of either selling to both the low type and the high type consumers, or choosing a price such that only the high type consumers can buy the good. Okay, so if you try to sell to both types of consumers, then the demand you face is going to be the sum of the two demand curves. Okay, so it's going to be 1 minus P plus A minus P. So that's 1 plus A minus 2P. Okay, so the profits are going to be price times 1 plus A minus 2P. So what am I doing here? Okay, so we can take a 2 outside. So this is just the same as 2 times this thing divided by 2 minus P. So then we know that this is 0 when P is 0 and when P is equal to this thing. Therefore the optimum must be half of this. Okay, so the optimum price is 1 plus A over 4. So at that point the total quantity, just substituting this thing into our expression for total quantity, we have 1 plus A minus 2 times 1 plus A minus 2 times the price. Okay, here's the price. So this is 1 plus A minus 2 times this. So 2 times 1 plus A over 4 is 1 plus A over 2. So we have 1 plus A minus 1 plus A over 2, which is just 1 plus A over 2. Okay. So with price discrimination we had output of 1 plus A over 2. Without price discrimination but selling to both markets, we still have output of 1 plus A over 2. Okay, so if without price discrimination the firm would want to sell to both high-type consumers and low-type consumers, then output hasn't increased, so welfare can't have increased. Okay, so price discrimination is going to be bad for welfare if, when there's no price discrimination, the firm is selling in both markets. But the firm might not want to sell in both markets. Okay, the firm always has the option of just selling to the high-type consumers. Okay, if it does, then it faces the demand curve of 1 minus P, which was the demand from the high-type consumers. So they're going to set a price of half to a quantity of a half. So in that case, output would have gone from a half to half without price discrimination to 1 plus A over 2 with price discrimination. Okay, so if without price discrimination the firm only wants to sell to the high-type consumers, then there's a possibility that welfare might have increased. Output increases, so we know that welfare could have increased. And there's an exercise here, yeah, which I'll leave as an exercise, we'll do it in the class. So, you know, we'd like to know when the firm will decide to sell in both markets, when they'd like to sell in one market. Okay, so in order to do that, we need to work out the profits when they sell in both markets, the profits when they sell in one market, and see when one is higher than the other. Okay, and it turns out that they'll sell in both markets only if it's constant A, which was the intercept on the low type's demand curve, only if that was bigger than square root 2 minus 1. So square root 2 is 1.4 something, so this is about 0.4. Okay, so if the low type consumers have at least 40% of the demand of the high type consumers, then the firm would want to sell to both types. But if the low type consumers have, I don't know, 30% of the demand of the high type consumers, then without price discrimination, the firm would only sell to the high type consumers. So the possibility of price discrimination is going to enable them to start selling in both markets, and it's going to increase total output. Okay, so possibly work. Okay, so we've seen the three main types of price discrimination. But there are a few other little topics that normally get lumped in with price discrimination because they're going to be discriminatory in some way. One thing that's often discussed is tying, okay, and that's selling. So that's selling. There are two goods you want to sell. Okay, for example, printers and printer cartridges. By being clever about the price of printers and printer cartridges, you can enact something a bit like a two-part tariff that's going to enable you to get extra profits as a monopolist. So, you know, you can buy a printer, you can sell a printer. Okay, clearly printers are resellable, so a firm can't stop you selling printers. So, if there are people who really value being able to print and people who only print very rarely, they're still going to have to pay the same amount to buy the printer. But maybe the people who don't buy a printer very often, who don't print very often, they're not going to use many printer cartridges. Okay, whereas business people are going to use lots and lots of printer cartridges. Okay, so even if you can't price discriminate on the printer, maybe you can then make the money up by charging a price above marginal cost on the printer cartridges. Okay, so tying is forcing people to buy related products from you rather than someone else. Okay, so I don't know, if you buy a printer from Epson or Canon, you then have to buy Canon printer cartridges. Okay. And these are priced way above marginal cost, because if you go on the internet for those kits you can buy with ink to refill old printer cartridges, and they're a tiny, tiny fraction of the cost of buying new printer cartridges. Okay, so Canon really want to stop you using those kits to refill printer cartridges. They say if you do that, you violate your warranty. They make it as hard as possible for you to use printer cartridges from somewhere else, so that they can get away with charging price a long way above marginal cost for the cartridges. So you can think of it as a kind of two-part tariff, okay, with the printer being the fixed cost and the cartridges being the marginal cost. Yeah, so don't look at Oz-Shai's definition of tying because it's a bit strange. So the usual one is that the purchase of one good is going to require the purchase of other goods in the future. Okay, so the printer and the printer cartridges are tied together. And it turns out that with tying, whether this is good or bad for welfare is going to depend on whether output increases or not. Okay, so maybe if it wasn't for being able to price printer cartridges above marginal cost, so if it was competition in the printer cartridge market, maybe Canon would sell printers at an incredibly high price in order to recoup, in order to make some profits. Okay, and at this high price, people wouldn't buy printers to print out their photos. Okay, it would be only business people who bought those printers. With tying, the firm Canon can sell printers at a low price, but then printer cartridges at a high price. Families who want to print out photos, they're not going to buy many printer cartridges, so they effectively get a low price for the total bundle. Businesses who have to do lots of printing, they're going to buy lots of printer cartridges, and they're going to pay a high price for the whole bundle. So, so if we go from a situation where the low-type consumers aren't buying a product at all to a situation where the low-type consumers are buying the product because of the possibility of tying, then welfare is generally going to increase. But if without tying, people would still be buying printers to print photos, then welfare is probably going to go down. You're looking terribly bored. Okay, bundling is another related thing. Maybe this will wake you up a bit. So bundling is pure bundling is selling two goods in fixed proportions. Okay, so Sky is a bundle of TV channels. If you get Sky Sports, but you also get a History Channel. Or Discovery, I've said. So you can think, suppose we're two types of consumers in the world. We're jocks and geeks. Okay, so I'm a geek. I don't particularly like Discovery Channel, in fact, but I don't. So the geeks like Discovery over Sky Sports. They value Sky Sports at 8, but they value Discovery at 12. Their total value for the whole bundle of Discovery and Sky Sports is 20. The jocks really like being able to watch football, so they value Sky Sports at 15, but Discovery at 10, and their total value is 25. So if Sky were to sell the channels separately, then they'd end up pricing, suppose we're even numbers of jocks and geeks, okay? Then they'd price Sky Sports at 8, so that both types would be prepared to buy. Okay, so that makes a total profit of 16, which is higher than the profit they would get if they just sold at 15 to the jocks. They're going to sell Discovery at 10. Okay, if they sell Discovery at 10, they make total profits of 20. Whereas if they just sold to the geeks by pricing at 12, they make profits of 12. Okay, so their total profits are 8 plus 10, so 18. So if they couldn't sell the bundle of channels together, the firm would make profits of 18. But if they can sell the bundle together, then they can sell the bundle at 20. So rather than selling the two channels individually and getting profits of 18 overall, they can sell the bundle and make profits of 20. And this is because by selling the bundle, you're able to make up for the fact that these people have opposite preferences. Okay, so you're forced to sell a low price for Sky Sports, because if you didn't sell a low price, the geeks wouldn't buy at all. Whereas you're forced to sell a low price for Discovery, because if you didn't sell a low price for jocks, you wouldn't buy at all. Okay, so people's preferences are negatively correlated. So when you sell a bundle, it's like you're averaging over that negative correlation. So on average, people's preferences are actually quite similar, and that means you can extract more money per unit sold. Okay, if you like, you're kind of inflicting Sky Sports upon the geeks and Discovery upon the jocks. You know, you're making them pay for something that they don't really value that much. So there's an exercise here. How would this change if jocks valued Sky Sports at 17? Okay, so if jocks valued Sky Sports at 17, then if Sky sold Sky Sports at a price of 8, it would be making profits of 60, selling to both types of consumers. Whereas if it sold Sky Sports at a price of 17, then the jocks would still buy. Okay, so even though the geeks don't buy anything at all, it still makes higher profits. So if the jocks value Sky Sports at 17, the profits from selling Sky Sports separately would be 17. Is this going to change the bundling outcome? So it would be 17 plus 10, which would make 27. Whereas if I sell the bundle, it would still be 27 and 20. Okay, so very different. Does that make sense?
They're better off if they bundle.
If they bundle, they make 27.
They make 40, wouldn't they?
They make 40 still.
Oh yeah,
20.
yeah, I can.
It doesn't matter.
But
It
it
doesn't-
does affect the
yeah.
profits if they sold separately.
Yeah, you're right. I was forgetting what I was doing. Okay, if they bundle, they make 47s. They make 40 still. Okay, if they sell for a lower price of the two. If they don't bundle, they make, whatever I said before. 27. Okay. So it doesn't change anything. Okay, so we've done that. So this is pure bundling, where you sell two goods in fixed proportions. So by fixed proportions, I mean you have to get the two goods together. Okay? You have to get both Sky Sports and Discovery. You don't have a choice of either getting Sky Sports on its own or getting both Sky Sports and Discovery. Okay? You either get nothing or you get both. That's pure bundling. Mixed bundling. Things stop working again. So mixed bundling is giving people the choice of whether they want everything together or if they want the components separately. Okay, so in fact, when you get a Sky subscription, you can choose if you want extra Sky Sports channels, I think. So you can pay extra to have some channels. Okay, so here's a tedious example about Word and Excel. Okay, so Office is a bundle of Word, Excel, PowerPoint, all these other things. Some people only use Word, some people only use Excel. But you can buy Word and Excel separately, or you can buy Office. So if you're Microsoft, how are you going to price Word, Excel, and the bundle in order to maximize your profits? So here we've got three different types of users: writers, accountants, and generalists. Okay, so we've got 40 writers, 40 accountants, 20 generalists. Writers value Word at 50, because they're writers, that makes sense. They never use Excel. So their total value for Office is going to be 50. The accountants only use Excel. Again, they have a total value of 50. And then these generalists, well, they use both Word and Excel. Their total value is going to be 60. Okay, so the challenge for Microsoft is decide on prices for Word separately, Excel separately, and for bundle, such that you maximize profits given these valuations. So, here I go through a few different strategies. It's generally the only way to work out what the optimum pricing is just to try all the different possibilities. Okay, so you might want to sell both Word and Excel at 30 in order to persuade everyone to buy. Okay, the price of 30, everyone's prepared to buy Word, everyone's prepared to buy. These people are prepared to buy Word, these people are prepared to buy Excel. Okay, so how many copies of Word do you sell? Well, you sell 20 to the generalists, 40 to the writers, say 60. Likewise, Excel, you say 40 to the accountants, 20 to the generalists, say 60. So in total, you sell 120 units at a price of 30 per unit, okay, which makes 3,600. Another thing you might like to do, well, you might like to sell Word and Excel at 50, which is what these writers and accountants were prepared to pay. So if you sell them at 50, the generalists aren't going to buy either Word or Excel. So you're selling 40 copies of Word, 40 copies of Excel. Okay, so in total you're selling 80 units of 50 per unit, which is making slightly higher profits. But these generalists currently aren't buying anything at all, which suggests that we might be able to do better than that. What about if we do the pure bundling thing?
Wouldn't that strategy all 120 buy?
Making a mistake.
Because if you're selling both of them for a price of 50, even if you only want one, but you value it at 50, you may as well get the other one free. So all the writer would buy it on the basis of a Word, and the accountant would buy it on the basis of Excel, and the generalist gets them for 25 each.
So is that not what I've done? That's what I've done, isn't it? So 100 units, 40 plus 40 plus 20. Okay.
I made that make money.
Okay, so strategy 3, well, let's suppose you do pure bundling. You sell Word and Excel together at a price of 50. 50 is for valuation of the writers and accountants. Generalists value it more. Everyone's prepared to buy at a price of 50. So in total you sell 40 plus 40 plus 20. It's 100 units at a price of 50. So you make a revenue of 5,000. So pure bundling is giving you slightly higher profits. Okay, well, another thing you might do is you might set a price of 60 for the bundle. That'd be a bit silly because these guys aren't going to buy anything at all. You're just going to sell 20 units to make 1,200. But maybe you can combine this strategy and this strategy. Okay, so you can sell a bundle at 60 and Word and Excel separately at 50. So the writers and the accountants, they're not prepared to pay 60 for the whole bundle, but they are prepared to pay 50 for the product separately. So you're going to sell 40 copies of Word at 50, 40 copies of Excel at 50, but then these generalists, well, they're not prepared to pay 50 for either Word or Excel, but they are prepared to pay 60 for the whole of Office. Okay, so you're going to sell 20 copies of the whole of Office at 60. So in total you make 80 times 50 plus 20 times 60, which is this one plus this one, so 5,200. Okay, so the optimal strategy here is this mixed bundling thing, where you sell the bundle together, but you also sell the product separately. Okay, and what's optimal in any given circumstance is going to depend on how many of the types there are, what people's relative valuations there are. Okay, and you just have to check the possibilities. Okay, and this is clearly price discrimination because these are different types of consumers. Every time I press back, it dies for some reason. Okay, so in all of the examples we've seen so far, price discrimination has been good for the firm. Okay, by performing price discrimination, the firm's profits have increased. And you might think that it's automatic that price discrimination is going to increase firm profits. But in fact, there are going to be two big counterexamples to that. One we're going to see now, and the other one is in the price discrimination lecture. Okay, so the first counterexample is the sale of durable goods. So if you sell a durable good, like a washing machine or a car, people have a choice of when they buy the good. They can buy it today, or they can buy it tomorrow. So if you like, you have two different markets. You have people who buy today and people who buy tomorrow. And price discrimination in this context is going to be selling a different price today than you are tomorrow. Okay, it's price discrimination because you're selling different price of the same goods. Okay. But with durable goods, what happens? Well, if it's suppose for 2 periods, there's today and tomorrow, eventually everyone wants to buy a washing machine. Okay, so maybe the people who really value washing machines buy a washing machine in the first period. In the second period, everyone left over buys a washing machine. Maybe mobile phones are a better example, right? A new iPhone comes out, it's priced at 500 quid, 6 months later it's priced at 200 quid. Okay, so the firm knows that the people who really want the product are going to buy straight away, and the people left over in the second period are going to be people who don't value it so highly. But if you're okay, so the firm is tempted to price discriminate in this way, to set a high price today and a lower price tomorrow, in order to extract some surplus from these people who don't value it so highly. But if you're one of the people who does value it highly, and you know the price is going to be very low tomorrow, even if you really like the good, you're still going to be tempted to wait. Okay? So the firm would actually like to be able to commit to set the same price in both periods. Because if the firm could set the same price in both periods, then no one would have an incentive to delay purchasing the product. Okay? And that can actually increase the firm's overall profits. So we'll see that in a very, very simple example. So suppose we've got 2 periods. Okay, well, I might not go through all of the maths of this, but I'll see how we can. Okay, so suppose consumers, consumers are distributed on a line from 0 to 1. People's location on the line is a measure of how much they value the good. Okay, so there are some consumers who value the good at 1, some consumers who value the good at 0, and some consumers with every value in between. Okay, so is that clear? So, this means that half of all the consumers are going to have a value less than half of all consumers are going to have a value bigger than half. 2/3 of all consumers are going to have a value above 1/3, etc., etc. Okay. So if some customer gets a value of V for each period that they have the product, okay, so they get, if it's a 2-period game, if you buy in the first period, you can get a total of 2V. So your surplus, if you buy in the first period, is going to be 2V minus the price you pay in the first period. Whereas if you buy in the second period, you only have the good for 1 period, so you make a surplus of V minus P. We're going to assume the firm has 0 marginal cost, and we're going to assume the firm sets the price of P1 in the first period and P2 in the second. So if the firm could commit, okay, the firm would set the same. Okay, so we're just supposing that the firm can commit to set the same price tomorrow as it does today. Okay, so some firms try to do this. So they say that if we ever have a sale in future, we'll refund you the difference. Some car firms do that. So if you knew that the price was going to be the same tomorrow as it is today, then there'd be no point you delaying. If you've got a choice between making 2V minus P and V minus P, you're going to choose to get 2V minus P. So if you knew for certainty the price was the same tomorrow, you'd want to buy today, not tomorrow. So who's going to buy? Well, all of the customers who make positive surplus. Okay, so all of the customers with 2v minus p positive. So all of the customers who value it at least p over 2. So what's the firm's profit? Well, profit is price times quantity. So how many consumers are there with v bigger than p over 2? Well, the total length of a line is 1. Maybe here's p over 2. These consumers have a high enough valuation to get positive surplus. How many of them are there? Well, 1 minus p over 2. That's the length of that line. So the firm profit is going to be price times 1 minus p over 2. Okay, so the optimum price, yeah, so if we take the 2 outside the bracket, this is a half times p times 2 minus b, so the optimum price must be 1. Okay, so if the firm could commit to set the same price in both periods, it would set a price equal to 1, so the demand would be so P is 1, so this is 1 minus a half, so demand is a half, and profits are going to be 1 times a half, so a half. So if a firm could set the same price in both periods, make a total profit of 1/2. So if you like, this is not discriminating, not making a function of, not making the price you get charged a function of when you buy the product. But in practice, firms can't commit. It's very hard for a firm to commit not to reduce its price in future. So what's going to happen? Well, in period 1, the Q1 consumers with the highest valuations are going to buy the product. Okay, we're going to solve for Q1 later. But if you like, what's happened is in period 1, the people who really like iPhones buy the iPhone. So maybe this distance here is Q1. So this chunk of demand has just disappeared. The remaining demand is 1 minus Q1. Okay? This is the demand that's left over in the second period. And these consumers have valuations from 0 up to 1 minus Q1. If you had a valuation above 1 minus Q1, you would have bought in the first period. So any consumers left must have a valuation less than 1 minus Q1. The value from buying in the second period is V minus P, that's the surplus you get. So consumers are going to buy in the second period if their value from buying is higher than the price they pay. Okay? So if this is P2, all of these consumers here are going to be prepared to buy. Yeah, anyone who values the good more than P2. So how many consumers are there in this wiggly line? Well, it's 1 minus Q1 minus P2. Okay, so total demand facing the firm is 1 minus Q1 minus P2. Okay, the same thing is normal, that's going to be maximized when P2 is 1 minus Q1 over 2. So if a lot of people buy in the first period, you want to set a low price in the second period. Okay, if a lot of people buy in the first period, it means all of the high value people have already bought. So the people who are left over have quite low valuations, therefore you want to set a low price to sell to price. What profits is the firm going to make in the second period? It's making, the price is 1 minus Q1 over 2, the quantity is 1 minus Q1 minus half that. Okay, so the total quantity is going to be that. Okay, so the profits are this thing squared, 1 minus Q1 squared over 4. I know I'm going quickly. I just want to give you the idea of this. Yeah, I think you can safely conclude that the details of this are unlikely to be in detail, but it's still important to see, I think. Okay, so we solved for the second period game. What now happens in the first period? So if you're a consumer, you've got to decide whether you buy in the first period or in the second period. If you buy in the first period, you get 2v minus p1. If you buy in the second period, you get v minus p2. So you're going to buy in period 1 if this thing is bigger than that thing. As long as this thing is positive. Okay. So you buy in the first period if you get high surplus from buying in the first period from buying in the second, and if you make positive surplus in the first period. So just rearranging, don't worry too much about the details, this just means you're going to buy if your value is higher than P1 over 2 and with this difference in prices. Okay, you can get that just by rearranging these two intervals. So suppose we make an educated guess that the price set in the first period is going to be less than the difference in the two prices. Okay, this is just a guess, we're going to verify that it's correct. Okay, so we're guessing that this thing is smaller than that thing. So if that's the case, then the consumers who are going to buy in the first period are the consumers who value it more than P1 minus P2. Okay, how many of those are there? Well, it's just 1 minus that quantity. So the quantity you buy in the first period is going to be 1 minus P1 minus P2. We know what P2 is. P2 is this, it's a function of Q1. Substituting that in, we get this expression. Okay, so we've got Q1 on the left-hand side, we've got Q1 on the right-hand side. A little bit of algebra gives you that Q1 is 1 minus 2/3 of P1. So then the firm's profits are going to be price you set in the first period times the quantity demanded in the first period plus the profits from the second period, which we've already solved for. Okay, so profits from the second period were here. All we've done is plugged in this expression for Q1. And I'm not going to go through the details of maximizing this, but it turns out this is maximized at a first period of price of 9 over 10. So quantity in the first period is 2/5, it turns out. Price in the second period is 3 over 10. So if you like, price has gone down from 0.9 to 0.3. So consumers know that the price is going to be really a lot cheaper in the second period. And remember we made this assumption to start with, and you can verify that the assumption is actually satisfied. So when you substitute these things into profits, what you find out is that the profits with price discrimination, okay, with setting a different price in both periods, is 9 over 20. Whereas when the firm could commit to set the same price in both periods, the profits were equal to 1/2. So being able to charge a different price in the two markets, the market today and the market tomorrow, actually reduces the firm's profit. The firm would like to be able to commit to set the same price today and tomorrow in order to encourage everyone to buy now, which is generally better for them. So occasionally, there have been a few instances where firms have managed to make these commitments. Okay, so Chrysler has a lowest price guarantee, where if a price is low in future, they're going to reimburse you the difference. Another way you can get around this problem of price discrimination for durable goods is by, rather than selling your product, you rent it. Okay, if you rent, say, a photocopier, then people face a separate decision on whether they have the photocopier today or tomorrow. Just because they have it today doesn't mean they're necessarily going to have it tomorrow. So there's no incentive to wait. You know, you're paying just for a photocopier today, not for the photocopier both today and tomorrow. Okay, so by renting, you can actually increase your revenue as a firm in this circumstance. Okay, yeah, it's because people are paying every period, so there's no point them delaying. Here it is. So, okay, let's have a break. Wake up our friends in the back. We've got she said okay, so the next topic I want to cover is price discrimination, price differentiation. Okay, so in all the models we've looked at so far, we looked at purchasing competition, cornering. Every firm was selling the same good. So, because every firm was selling the same good, whereas price competition, where price was driven down to marginal cost. But in practice, no two firms sell exactly the same good. Even if you buy two different types of coffee or two different cans of baked beans, they're going to be slightly different ingredients. The Tesco value version is going to be worse than the Heinz version.
Apparently they're all manufactured in like the same factory. It's like
well, even if the contents are the same, you might kind of have a shame quotient associated with buying Tesco value.
You know the one that really confused me? Like how you got different stir-fry packages?
Yeah.
There's Tesco value stir-fry. And like, how do you get value vegetables?
Well, they're always slightly mouldy, aren't they? I think that's outside of my domain of expertise. Okay, so we're going to look at two types of product differentiation. So there's horizontal product differentiation, which is when firms are producing different types of products, if you like. So different consumers are going to prefer different products. Okay, so some people like Cheerios, some people like Crunchy Nut. And there's vertical differentiation, where firms are producing different qualities. So if Tesco value baked beans and Heinz baked beans were the same prices, you can maybe assume that everyone would rather buy the Heinz. Okay, but because they're different prices, maybe some people value quality more than other people. Okay, so some people are going to end up buying the Tesco value because they just don't care that much. Okay, so vertical, everyone has the same preference. Horizontal, different people have different preferences. And then within horizontal differentiation, we're going to be looking at two classes of models. The first class are kind of exogenous differentiation models. This is where a firm enters the industry and it's magically creating a new product. Okay? The firm doesn't have to decide what type of product to create. If you enter the industry, you're automatically differentiated from your rivals. And the Dixit-Stiglitz model is the most famous example. And you might have seen this in macro, you might not. So it's used in macro a lot. And then under endogenous differentiation, we're going to look at the hoteling model of location choice. Okay, so hoteling is the name of the guide, not that it's a model about hotels.
Location. Yeah, where's the hotels going?
Yeah, what's the name? So you've seen this already, have you?
Well, yeah, but he never really explained that part of it.
Okay, well, there's a bit of overlap, so it'll be easy for you. Okay, so we'll look at hoteling, which might be old news for some of you. We'll look at price discrimination in the hoteling setup, and then we'll look at the salad model, which is so the hoteling model. For if you speak French, that's funny. So the hoteling model, if you like, consumers are going to be arranged along a beach. And people are going to be walking along the beach to get ice cream, but people are lazy, they don't want to walk too far to get ice cream. Okay, so it's a straight line in the hoteling model. In the salad model, consumers are going to be arranged on a circle. That's going to be the difference. And then, next week we'll get to vertical differentiation. Okay, So why are we interested in product differentiation? Well, we want to know how firms choose what products to produce, what products there might be a demand for, how different their product should be from their rivals. Okay? If you think about, you're going to open a new restaurant, should you open an Italian restaurant or should you open a Greek restaurant? Well, you want to know what your rivals are producing, you want to know what consumers' tastes are. Maybe the optimal restaurant to introduce is a fusion restaurant that's kind of halfway between the two or something. Yeah, product differentiation is clearly going to affect price competition. If firms are producing completely different products, then it's like those firms are all monopolists. Whereas if the goods aren't substitutes at all, then it's like the firms are monopolists. If the goods are perfect substitutes, then we're going to get price as marginal cost. Okay, so the degree of competition is going to depend on how close a substitute the goods are. And then we're going to be wondering whether too many different types of products get produced or whether too few types of products get produced. Okay, so the laptop's died again. I don't know what's going on with my laptop. This Dixit-Stiglitz model that's used a lot in macro is going to be a model of exogenous differentiation. A new firm entering is going to be producing a new product. And you can think of it as a model of preference for variety. I do that a lot. So.
Oh, I
Okay, well it's fine. So like breakfast cereals, you know, there are millions of different types of breakfast cereals. People seem to like having a variety of breakfast cereals. People like having choice. And we're going to simplify things a bit with the Dixit-Stiglitz model. Rather than assuming that some people like Honey Nut Cheerios, some people like Kellogg's, cornflakes, we're going to assume that there's just one person who likes a bit of everything. Okay? So it's kind of like a representative consumer. And it's there just as a simplifying assumption to make things easier. You know, really we're thinking about different people liking different products, but to make our life easier, we're just going to think about this representative consumer who wants a bit of everything. Okay, so I think this is the first time so far that we've actually seen a consumer's utility function. So everything we've looked at so far has been for firms, whereas here the action is going to come from the consumer side. So suppose you've got a representative consumer and their utility is given by Q0, where Q0 is, if you like, it's money. It's the quantity of money they have left over to spend on other things, plus C, where C is going to be this aggregate over the quantities of the individual goods that they consume. Okay, so we're going to have N firms, N firms, each producing a different good. Firm 1 is going to produce this good 1, firm 2 is going to produce good 2. Q1 then is measuring the quantity of good 1 that the consumer consumes. Q2 is the quantity of good 2 that the consumer consumes, and so on. And this aggregate takes a very specific form, okay, where we have each quantity raised to some power, and then we kind of undo the raising to a power at the end. And this sum thing just means exactly the same as well. Okay, this is the sum from I is 1 to n of the qi is raised to this power. Just this thing. Okay, so as I said, good 0 is going to be money. It's a good that's useful for other things. And good I is going to be produced by good I, by firm I. And one thing you can notice straight away is that if another firm enters, you know, suppose another firm enters and it's going to sell quantity 1, that's going to make consumers better off. Okay, the more firms there are, the more different things they're consuming, the higher this is going to be, the happier the consumers are. Okay, so consumers like variety here. Consumers like being able to consume all of these different types of breakfast cereals. Another property of this utility function is that all of the goods are going to be equally close substitutes. Okay? If you wanted to, you could work out the elasticity of substitution between different goods here, and you'd find that it was just a function of lambda. Okay. So lambda, if you like, is going to control the elasticity of substitution between goods. When lambda is naught, this is 1 plus lambda, so 1 plus naught. So this is 1. This is 1 over 1 plus lambda, so 1. So when lambda is 1, this is just a sum. This is just q1 plus q2, etc., etc. Okay, so when lambda is 1, the goods are perfect substitutes. The consumer is indifferent between buying another unit of good 1 and another unit of good 2, if they're the same price. Whereas when lambda goes to infinity, the goods get less and less substitutable. Okay, so when lambda is at infinity, the goods are going to be the opposite. Very poor substitutes. And Oishai goes through the maths just of a lambda equals 1 case. And so with lambda is 1, this is squared, and that's a half. So maybe that's an easier special case to look at. Okay, so what's this consumer going to do? Well, they want to maximize utility, but they've got some budget constraint. So suppose they have a total income Y. They spend Q0 on money, so the price of money is 1. And then they buy QI units of good I. Price of good I is PI. So their total budget constraint looks like this. Okay. So it's Q0 plus P1 times Q1 plus P2 times Q2, etc., etc., has to equal their income. So because of this budget constraint, Q0 is equal to Y minus this sum. Okay, the money you have left to spend on other things is your income minus what you spend on each of the goods. So you can substitute, here the utility was Q0 plus C. We know that Q0 is Y minus this sum. So let's substitute Q0 out of their utility. Okay, so their utility is going to be given by this expression. All we've done is just substituted out Q0. So this is the consumer's utility. The consumer wants to decide how much of each good to consume. So there's going to be a first order condition for Q1, a first order condition for Q2, etc., etc. Okay. So let's look at the first order condition for Q1. So Q1 occurs here with a coefficient minus P1. So that gives us the minus P1. And then Q1 occurs within this messy expression. I know this is slightly intimidating, but really you just differentiate it using the rules that you're used to. Okay, so this is of the form, let's call this thing x. This is of the form x to the power of 1 plus lambda. Okay, well we know that to differentiate x to the power of 1 plus lambda, we get 1 plus lambda times x to the power of lambda. Okay, so here's x to the power of lambda. And then we need the derivative of what's inside with respect to Q1. Okay, so Q1 only occurs here, doesn't occur in any of this bit. Derivative of Q1 to the power of 1 over 1 plus lambda is 1 over 1 plus lambda times Q1 to the power of 1 over 1 plus lambda minus 1. Okay, it's just the rules that you're familiar with. So remember that but C was equal to this thing. So C was Q1 to 1 over 1 plus lambda plus Q and 1 over 1 plus lambda all to the power of 1 plus lambda. Okay, so C, so if we raise C to the power of lambda over 1 plus lambda, what do we get? Well, C to the power of lambda over 1 plus lambda is going to be this thing that we had before, Q1 all to the power of 1 plus lambda times lambda over 1 plus lambda. Okay, because remember, if you have x to the a all to the power of b, that's equal x to a times b. Okay. So here we've got this thing to the power of 1 plus lambda. So when we raise both sides to the power of lambda over 1 plus lambda, that gives us this to the power of 1 plus lambda times lambda over 1 plus lambda. That and that cancel. So this is that to the power of lambda. Okay. So this expression here is just c to the power of lambda over 1 plus lambda. This term up to there. We've got a 1 plus lambda here and a 1 over 1 plus lambda there. They cancel. P1 can go on to the other side. Okay, so all we're left with is this term, q1 to the power of 1 over 1 plus lambda minus 1. But 1 over 1 plus lambda minus 1 is 1 over 1 plus lambda minus 1 plus lambda over 1 plus lambda. Okay, so that's 1 minus 1 minus lambda over 1 plus lambda. Okay, so minus lambda over 1 plus lambda. Okay, which is what we have here, minus q1 to the power of minus lambda over 1 plus lambda. So since we can take the price over to that side, we know that the price that, if you like, this is their demand curve, the price they're prepared to pay is some constant, well, this thing c, times q1 to the power of minus lambda over 1 plus lambda. So this looks like an isoelastic demand curve. Okay, and the trick that Dixit and Stiglitz introduced was that when there are lots of firms, each individual firm isn't going to have a big impact on this C. Okay, if you like, the total bundle that the consumer consumes isn't going to be very affected by the price set by a particular firm. Okay, so what we're going to do is we're going to treat C as if it was a constant. So more recently, people look at the case when you don't treat this as a constant. In fact, I do this in some of my research, and when you don't treat this as a constant, you find that the markup will be a function of the number of firms. Okay, but here we're going to treat C as if it was a constant. So then this is like the demand curve based by the firm producing the first good. Sometimes my battery lasts for 4 hours. Now it's just going down incredibly quickly. Okay, I'm going to carry on talking just while I swap the battery of my laptop out. So where are we up to? Okay, thank you. Okay, so we've got a demand curve coming from this consumer's optimization problem. So the firms in the model are going to respond to that demand curve in the sensible way. Okay, so we know that we've solved for the monopolist problem of isoelastic demand 1,000 times, and really it's just going to be exactly the same thing. So because this demand curve is telling the demand for a particular good, okay, so given that demand curve, the firms act as if they're monopolists. Okay, so because the firms can act as if they're monopolists, we tend to call this monopolistic competition. So it's like all of the firms are monopolists. Okay, sorry for that. Okay, so what are profits? This is just like what you've seen before with a monopolist with isoelastic demand. They sell a quantity Qi, they set a price Pi, they face a marginal cost of CI. Okay, so substituting in for pi that we found before. So here we just substituted in for pi. So when we multiply out the brackets, well, this term is going to give us a CIQI, and then we have QI times QI to minus lambda over 1 plus lambda. Okay, so that's QI to the power of 1 minus lambda over 1 plus lambda. Okay, so this is what firm profits are. Firms choose quantities in order to maximize profits. So when we differentiate this bit, we get 1 minus lambda over 1 plus lambda times QI to this minus 1. Okay, but 1 minus lambda over 1 plus lambda is 1 plus lambda over 1 plus lambda minus lambda over 1 plus lambda. So 1 over 1 plus. Okay, so this power is just 1 over 1 plus lambda. Okay, so we're taking the power down, that's where we're getting the 1 over 1 plus lambda from. C just a constant, that stays there. And now we have this to the power of what it was before, minus 1. So we just lost the 1. Okay, so this is QI to minus lambda over 1 plus lambda. Okay, so taking, well, you know, it's the normal trick with isoelastic demand, right? We know that pi is equal to this thing. Here we have exactly pi. Okay, so this is just 1 over 1 plus lambda times pi minus ci. So when we rearrange, we have the price is 1 plus lambda times ci. Again, the reason I have these approximates is because we're treating c as a constant. That's where the approximation is coming from. You don't need to worry too much about that. Okay, so firms are setting a price equal to 1 plus lambda times marginal cost. So I said with lambda equals 0, we had perfect competition. Okay, so with lambda equals 0, the products were perfect substitutes. So in that case, we got price equal to marginal cost. As lambda gets bigger, the goods are worse and worse substitutes. We get price higher and higher above marginal cost. So that's, you know, it's quite a simple model to solve. Now, you've seen isoelastic demand quite a few times. So just as we did with Cornell and Bertrand, we might like to see what happens when there's free entry of firms. Okay, so suppose firms have to pay a fixed cost in order to enter. We pay a cost F to enter. And all firms are going to have the same marginal cost of C. Then, well, in equilibrium, firms are going to carry on entering until profits are driven down to 0. So the cost of entering is equal to the post-entry profits. Okay, so F is equal to price minus cost times quantity, which is profits. Well, price, remember, was equal to, PI was equal to 1 plus lambda times ci. Okay, so pi minus ci is just lambda times ci. So this thing is lambda times c if all firms have the same marginal cost. So yeah, so under free entry, the cost of entry must be equal to lambda times marginal cost times the quantity they produce. So even without, you know, we don't need to solve for the number of firms. Even without solving for a number of firms, we know that if there's free entry of firms, QI has to be equal to F divided by lambda C. Okay, so each firm is going to produce this quantity. So the higher entry costs are, the fewer firms are going to enter, and so the more each firm is going to produce. If markups are high, so if lambda is high, then it's very profitable to be in the industry. So lots of firms want to enter. So those firms that do end up producing less. That's why lambda's on the bottom here. And because profits are proportional to marginal costs, okay, if marginal cost is high, then lots of firms want to enter the industry. So again, each firm is going to be producing less. Okay, so it was maybe slightly surprising, but marginal costs actually increase profits. So another thing we might be interested in is whether or not there's too much or too little entry in this model. Okay, remember with Bertrand competition we found there was too little entry. Okay, with Bertrand competition only one firm was entering. With Corner competition we found there was too much entry. It's going to turn out that with this model there's exactly the right amount of entry. And we're not going to go through the maths to show that. But Dix and Stiglitz do it in their 77 paper, which you can read if you're feeling keen. Yeah, so to be a bit more precise, what they find is that the number of firms that enter under free entry is a constrained optimum. Okay, it's the number of firms that a social planner would choose if the social planner was free to set N, PI and QI to maximise total utility, subject to the constraint that the firm can't make lump sum taxes or transfers, and the social planner can't impose lump sum taxes and transfers, and firms have to make positive profits. Okay. So if the social planner faced these two constraints, they would choose to set exactly the same number of firms as enter under free entry. Okay, enter under laissez-faire, letting the market do what it wants. Okay, so with this Dix and Stiglitz model, it seems like the market is getting just the right number of firms to enter. So not too many, not too small. But this is a very specific result. Okay, it's not the case that you can think, well, maybe all competition looks like the Dix and Stiglitz model, therefore we don't have to worry about there being too much or too little entry to an industry. What happens with this Dix and Stiglitz utility function is that the two forces are perfectly counterbalancing each other. So if you slightly change the utility function, okay, so rather than having this power form, you just make a slight change to it, either one force or the other force will start to dominate. So the two effects that are at work, the first is what's called the non-appropriability of social surplus. And this is what we discussed when we were looking at Bertrand competition. Okay, a new firm that enters is going to benefit consumers because they value variety. And the firms in the model can't capture that benefit to consumers. So a consumer would like to pay a firm to enter because they value variety. Okay, if all the consumers could group together and take a decision as a mass, they would like to encourage new firms to enter because they like having lots of different breakfast cereals to consume, if you want. But a firm doesn't care about that. A firm is only thinking about its own profits. Okay, so the firm isn't internalising this variety benefit that its entry is going to have on consumers. So that's the force that means there's going to tend to be too little entry. Consumers like variety. Okay, firms don't internalise this benefit to consumers, therefore firms have too little incentive to enter. But just as with corner competition, there's also this business stealing effect. Okay, remember with corner competition, when another firm entered, it was just thinking about its own profits, but its entry is going to reduce the profits of all the firms already in the industry. Because after another firm enters, the aggregate price is going to be driven down, which is going to hurt everyone's profits. So this business stealing effect is going to be present here. When another firm enters, it's going to end up affecting the profits of all of the firms in the industry that are already there. So this is a next negative externality of entry, which is going to mean there's going to tend to be too much entry. Okay, and let's stop there because I don't think we can go on.
Yeah.
Okay, you're all looking very tired. Get some sleep. Party less.